Thank you for joining us for today's session, Leading Green Growth with Professors Ricardo Hausmann and Daniel Schrag, presented by Harvard Kennedy School Executive Education. Professors Hausmann and Schrag are the faculty co-chairs of the new Leading Green Growth Executive Education program launching this August. We'll talk more about that as today's discussion goes on. I will now turn it over to Professor Schrag to get us started with today's discussion. Dan?
Thank you so much. Welcome to everyone here. I think both Ricardo and I are very excited for today, but also for the program this summer and this collaboration we're starting with Ricardo's Growth Lab to really think about the opportunities of green growth in the future. I think it's in some ways one of the most exciting perspectives on the world, on how the world is likely to evolve over the next 50 years. And we're in the very early stages of watching this transformation. And I think it's incredibly exciting. What I want to do in the first 10 minutes of this webinar is give you a little bit of a perspective for the big picture, for what's happening with climate change and what's happening with energy technology and the transition, and kind of frame the big picture opportunity. Ricardo is then going to talk in more detail about economic growth and what this opportunity entails. And then I'll come back and offer some perspectives on why there may be some bumps in the road in terms of this energy transition, and why it's important for countries, for companies, for firms, and for individuals to really dig deep and try to understand this transition, because it's not going to be necessarily so quick or so simple, and there may be a variety of twists and turns. And that's what we're going to talk about in much more detail this summer when we teach our course. I'm going to share my slides now. Let me see if I can do that quickly. So this is the world. And I think most of you are aware that the world is warming. We've warmed about 1.1 or 1.2 degrees Celsius over the last, well, a little more than 100 years, 150 years. It depends a little bit on what we think about as the baseline. It turns out that we've actually known that burning fossil fuels and putting greenhouse gases, primarily carbon dioxide, into the atmosphere is actually going to warm the planet. We've known that for a very long time. This is a picture of a man named Svante Arrhenius, who in 1896 published this paper called On the Influence of Carbonic Acid in the Air Upon the Temperature of the Ground. Svante Arrhenius was a famous chemist. He actually was in some ways the father of physical chemistry, and he was the first Swedish scientist to win a Nobel Prize, which is some distinction. Essentially, in this paper and in a popular book he wrote just a few years later, he said that if we doubled carbon dioxide in the atmosphere from burning coal, which was the dominant fossil fuel back in 1896, that the Earth's temperature would raise by about 4 degrees Celsius. Now, he was wrong. I think today most climate scientists would say that's maybe just a little bit too high. It might only be 3 degrees Celsius. But given that it was 1896 without any computers, he actually did a pretty good job. It's pretty impressive. So this is not a surprise, the phenomenon of what's happening. We're not going to go today into the details of the physics of the greenhouse effect, but understand that we've known about this problem for a very long time. But what's changing is that we're actually watching it unfold. This, of course, is the famous Keeling curve. Dave Keeling started measuring CO2 in Mauna Loa, Hawaii in 1958. When he died in 2005, it was about 380 parts per million. When he started measuring it in 1958, it was about 315 parts per million. The details of this curve are complicated because only about half of the carbon dioxide that we emit when we burn fossil fuel actually stays in the atmosphere. About half is taken up by the ocean and taken up by trees, by the land. But that's the good news. Sort of the ocean and the land are giving us a little bit of a cushion. But in reality, we know this rise is due to burning of fossil fuels, and it's slightly accelerating. Most recent measurements are now above 420 parts per million and continuing to rise. We see the signs of the impacts of this, but before we go to that, I just want to give you my perspective as a geologist on this problem. We're really doing something extraordinary that's really unique, not just in recent history, but in the long geologic history of the planet. This is the same graph. This is carbon dioxide in the atmosphere now over the last 800,000 years of geologic history. And what you see is CO2 levels fluctuating in the atmosphere between lows of about 180 parts per million, highs a little bit below 300 parts per million. And that's the natural cycles of climate. Essentially, that's the waxing and waning of the ice ages. 20,000 years ago here in Boston, we were under a kilometer of ice or so. But in the last 120 years, carbon dioxide has shot up and is rising faster and faster. And you can see that we are now way above anything we've experienced in the last 800,000 years. And indirectly, we think it's been several million years since we've experienced anything like this. So we are the first humans, indeed, probably the first hominid species to experience the conditions that we're experiencing today. And it's going to continue to rise because of all the inertia in the system. When I talk to broad audiences about climate change, I like to emphasize that climate change is a super hard problem for two very simple reasons. I'm not going to talk a lot more about climate change today, but I want you to understand the big picture of what we're facing, what the world is facing. Climate change, because the atmosphere mixes, because the greenhouse gases mix in the atmosphere, it's a collective problem. It's a collective action problem that is truly global. What this means is we have a huge free rider problem. That is, we have to act collectively because what the Earth system really responds to is the cumulative emissions of carbon dioxide, because they last for a very long time in the atmosphere, and the global cumulative emissions. So, exactly what the US emissions are, or Chinese emissions, or India's emissions, or Europe's emissions, individually, we can focus on our own emissions, but we can't solve the problem individually. We actually need all of the major emitters to reduce their emissions to essentially zero to solve this problem. And even then, we haven't solved it because there's a huge amount of greenhouse gases in the atmosphere that the Earth is still responding to. And that brings us to the second problem. Oh, by the way, I should mention it's global, but it's not equal. And we'll talk about this in just a second. The second part of this is that just about every aspect of climate change has really long timescales. And when I say long, I'm a geologist. So we're talking about centuries to millennia to even tens of millennia. The timescales of the oceans, of the ice sheets, of the carbon cycle involve incredibly long timescales. And so this is not a system that's going to change quickly. And therefore, we've set ourselves up for substantial climate change in the future as we try to manage this problem. I want to show you the last 150 years just to give you a perspective on what's actually happened. This is a 5-year average of temperature. And so it's like the spatial footprint of global warming. The reason we take a 5-year average is because we don't want to see the seasonal variability or year-to-year variability. So we're really looking at the broad patterns of warming across the globe. And you're really seeing it coming on stronger and stronger over the last few decades. And again, this is a temperature anomaly map. So the scale on the left shows you the temperature relative to a mid-century average. And so this is average of 2-degree warming in red. And what you can see, I think, the Arctic is warming faster than the rest of the world, but I think you can see that the land is warming faster than the oceans. And that's actually consistent with the basic physics of climate change. But of course, the land is where we live. And we're seeing more and more impacts of that warming. But the timescales of the system, especially of the ocean, mean that this warming is going to continue even if we were to rapidly reduce our emissions. So we have a huge problem we've set ourselves up for, and the world is now scrambling to get ahead of it. The good news is that we are getting ahead of it. I'm going to skip some of this, but let me talk briefly about emissions and cumulative emissions. As I said before, the climate system primarily responds to cumulative global emissions of carbon dioxide. And that means the goal has to be net zero emissions. And even when we get to net zero emissions for the globe, there's still going to be a lot of warming that's going to occur because of the CO2 we already put in the atmosphere that's still there. But I want you to see this by country. So here is a graphic showing the contribution to cumulative global emissions of CO2. What you can see here is that the US is responsible for roughly 25% global emissions. The EU, 22%, Russia, 6%, China, 12.7%, although this is old, this is from 2019, and China's emissions are so high that they're now closer to 15%. But so they're growing fast, but they're still small compared to US and the EU. I want to zoom in on this lower right corner, though, for a second, because I think this really gets at this question, the fundamental unfairness of climate change. What you see, for example, in blue, this is the African continent. And if you take out South Africa, that's a big coal producer, and only look at sub-Saharan Africa, so you remove Egypt, Algeria, Libya, Morocco, and Tunisia, all of sub-Saharan Africa, led by Nigeria, that's a whopping 0.2% of cumulative emissions, all the rest of sub-Saharan Africa put together with Nigeria is still less than 1% of cumulative global emissions. The absurdity of that is just obvious. Asking African countries to reduce their emissions when they're likely to experience a very large share of the impacts of climate change seems absurdly unfair. And this is what I call the fundamental injustice of climate change. Many of the people who did nothing to contribute to the problem are going to suffer the worst impacts. But our course is not talking about how countries in sub-Saharan Africa or other poor countries around the world can reduce their emissions. If you look at this map, this is absurd. And by the way, this was emphasized recently. Sorry, I'm going to skip some of these things. This was recently last summer when we had in the Sindh Valley of Pakistan, incredible flooding, 30 million people displaced. And yet Pakistan has contributed less than 1% of global emissions. And yet they suffered unbelievably. And many of the op-eds in Islamabad were saying, you did this to us, you, the US, EU, China, other big countries that have emitted a lot of carbon dioxide, you caused this devastation. I think this unfairness of climate change is often talked about in terms of loss and damage or other similar terms. But what I think they miss is the incredible opportunity of climate change. And that is the incredible opportunity of decarbonization. Here is a graph showing world carbon dioxide emissions from 1970 to 2018. What you can see is that China from about 2000 to 2020 has gone on an incredible tear, this incredible rise of carbon dioxide emissions from building a huge number of coal-fired power plants. You see the rest of the world rising steadily. EU has been decreasing its emissions steadily over time. And in the last 15 years or so, the US has been slowly decreasing as well. But this change in energy systems that we're just on the tip of is going to be an extraordinary event. And that's partly brought about by technology. For example, solar and wind in particular are seeing a renaissance that is, even 10 years ago, would be unimaginable. The price of photovoltaics has come down dramatically. And this, you can see this is from the US. For the last several years in the US, wind and solar have represented about 75% of new electricity capacity installed. This was true when President Trump was in the White House, and he had an incredible hatred of wind energy. And it just shows you that economics trumps politics, at least in the US, most of the time. Many of these wind farms, for example, were built in Republican states where there's a lot of wind capacity. But this isn't just true in the US, it's actually true all over the world. I want you to look at this map for a second, and it's kind of an interesting and confusing one. This shows the percentage of electricity generation from renewable sources: hydro, geothermal, solar, biomass, and wind. What's interesting is the highest penetration, where you have 60, 70, 80% penetration of renewables, is actually some of the poorest countries in the world. Of course, that's not because they're green or that they're necessarily antagonistic to fossil fuels. It's that they're so poor that they actually just don't have much capacity. And so they rely on things, mostly hydropower, and a variety of other opportunities. It's a little bit of a false dichotomy. But if you look at the richer countries in the world, what you see is that slowly across Europe, you're hovering around 20% penetration of wind and solar. And even in the US, we're now at about 12 or 13% wind and solar penetration, growing fast because of the economics. But here's the big picture. This is solar power generation in 2020. And you can see the actual solar power installed around the world. Poor countries are mostly left out. There's what I call a renewables gap. You have high penetration in the US and China. Of course, this is total solar power generation. And so smaller countries automatically have less, and therefore they don't get the dark colors. But what you see is in Europe, in the US, and China, these are very high penetration. And sub-Saharan Africa is, in fact, most of the African continent has almost nothing. It's not that it's not sunny there. Just to remind everybody, and I think this is obvious, this is a map of what's called the global horizontal irradiance. That's like essentially what a solar panel in some ways would receive from the sun based on cloudiness and moisture in the air and other things. And you can see there's plenty of sun in Africa. We just haven't yet invested in the growth of renewables in those places. Same is true with wind. This is share of electricity production from wind around the world. And again, you can see it's the haves and have-nots. There are a few exceptions, Brazil, a few other places in Africa that have high penetration wind, but for the most part, Africa has very little. And that isn't because there's no wind. In North Africa, for example, here is a map of mean wind speeds. And you can see there's actually plenty of wind in North Africa. There's not much along the equator, but on the equator, there's plenty of sun and there's plenty of biomass. It's not just renewable energy. It's not just renewable energy and electricity. It's also the transition to clean technology. Here, for example, is just one example. This is the global sales and market share of electric cars, climbing rapidly over the last several years. In the US, by 2030, we expect to be somewhere around 30 to 50% penetration of EVs as a fraction of new car sales. Europe is already on that scale. In the UK, already above 25%. So this is an incredibly exciting time where there's a global transition in terms of energy technology. And I think the point that Ricardo and I want to get across is that this energy transition, driven by concern about climate change, represents perhaps the greatest opportunity poor countries have ever had to actually drive foreign investment and massive economic growth. The reason is not because they need to somehow reduce their emissions, not build coal plants, not somehow suppress their economic development. Just the opposite. What we're arguing is that this global energy transition, driven by many of the rich countries and their commitments to be green going forward, will actually, in the future, drive incredible opportunities for poor countries that are rich in renewable resources or rich in mineral resources that'll be critical to build things like lithium-ion batteries or other green technologies. That the commitments that Europe, the US, Japan, Canada, all of the rich countries of the world have made represent a kind of shuffling of the deck, a new playing field that will provide incredible opportunities for the countries that make the right investments and the right decisions. So the question is, what can these countries do to promote this green growth pathway? What can these countries do to derive the kind of investment that will see long-term economic growth and a complete transformation of their economies? And on that note, I'm going to pass it over to my colleague, Ricardo, and then maybe come back a little bit and talk in more detail about some of the energy technology.
Hi, everybody. Good morning, good afternoon, good evening, wherever you may be. It's really, really an honor and a pleasure to be with you and to be with my colleague, Dan Schrag. He's been my friend for many years. This is the first time we are co-teaching a course, and I'm sure I'm going to learn a hell of a lot from the experience, from the participants, and from Dan. So let me share my screen also, and hope you're seeing everything fine. I wanted to focus on this idea. I mean, my area of expertise is growth. My focus is how to make countries grow. And this is a picture of world growth since in the last 200 and so years, since 1800. And you see that essentially incomes per capita in the world were fairly flat for a very long time. And then something started to happen in some parts of the world, that they became rich, and other parts of the world lagged behind. So the differences in income between countries, if you measure them, say now, they are huge relative to where they were in the past. And this global growth that happened predominantly in some parts of the world, say in the West and in Japan, was accompanied by a huge increase in the use of energy. And that increase in the use of energy came mainly first from coal, then from oil, then from natural gas, and so on. So there's actually a very strong relationship between how rich you are and how much energy you use. The relationship is not perfect, but it's pretty strong. Now the world is becoming less intense, and it's able to produce more dollars per unit of energy that it produces. But rich countries just use much more energy than poor countries, and this is what this graph is telling us. Now, as Dan was saying, you know, the countries of the world, these are not cumulative emissions, these are current emissions. The countries of the world are very focused on lowering their emissions and on trying to have everybody lower their emissions, but you see that none of them can actually make a big difference on their own. So everybody's relying on everybody else contributing to lowering emissions. And these emissions in per capita terms are very different between the different countries. What I like about this graph is that on the x-axis, we have the population of the country, and on the y-axis, we have the per capita consumption of each country. And so every rectangle you see is proportional to how much CO2 is being emitted in these different countries. And you see that the US is thinner but taller than China. So China has more mass than the US here, say the size of the rectangle, but that's because there's many more people in China than the US, but actually per capita, Americans are emitting about twice as much as China. But the interesting thing is that for the rest of the world, it's very little what they get to emit. So right now, in the process of trying to make everybody, you know, help out in lowering emissions, the accent has been on, you know, what will your country do to lower its emissions? If the world is going to lower its emissions, then every country needs to lower its emissions, every company needs to lower its emissions, every region needs to lower its emissions, every city needs to lower its emissions. What are you going to do to lower your emissions? And this course is based on the idea that there's a fundamental fallacy of composition in thinking about the problem in that way. That for the world to lower its emissions, a lot of things need to happen. This is going to be a fundamental transformation in the structure of the economy. So coming from the Kennedy School, Kennedy School, our motto is derived from John F. Kennedy saying, ask not what your country can do for you, ask what you can do for your country. We would say, ask not what you can do to decarbonize yourself, ask what you can do to help the world decarbonize. Ask what your country can do to help this global transition of decarbonization. So don't look at your navel and asking, what are you going to do to lower your emissions? Ask, what can you contribute to a world that is trying to lower its emissions? Because those things that the world will need to try to lower its emissions are going to be the fast-growing markets of the coming years. And if you can carve out a role for your country in those fast-moving markets, then the decarbonization agenda is going to propel your growth. So in that sense, I think we are trying to understand this. What are the changes to a global economy that are happening, and how countries can tap on those transformations to propel their growth forward? So the green growth is not about focusing on things you can do just to lower your emissions. It's really focusing on how you can help the world lower its emissions. Now, what does the world need to do to lower its emissions? Well, the world is emitting a lot of stuff because it's making things and manufacturing, uses energy, produces CO2 for other reasons. We are using CO2 to generate electricity. We generate greenhouse gases through agriculture, for the fertilizers that we use, for the methane that animals emit, etc. We use emissions for transportation, in our cars, in our trucks, in our buses, in our airplanes, in our ships, and we emit also to cool off and to warm our buildings and to build our buildings with cement and steel and so on. So what will the world need to lower its emissions? Well, there are several strategies that are already out there. You need to electrify everything that can be electrified, and then you want to generate that electricity in clean ways. You want to develop alternative fuels for things that are going to need liquid fuels, whether it's green hydrogen, green ammonia, or methanol, or green hydrocarbons. You'll want to eliminate emissions from the manufacturing process, maybe find other chemical reactions, say to reduce minerals so that you don't emit CO2 in the process of reducing them, maybe by using hydrogen instead of coal or natural gas in the reduction process. We'll need to capture CO2 because everybody talks about net zero. It's very hard to get to gross zero. So we need to capture that CO2, and then we have to figure out what the hell to do with that CO2 that we've captured. And there's going to be an enormous amount of uncertainty of how to push any of these agendas forward. But that's sort of like the technological exploration that the world is going to be doing. So, question, who will be producing all of these things that will be needed for decarbonization to happen? And how can you grow by helping the world decarbonize? What is it that you can do to participate in all of these things that the world is going to need? I'm going to describe 5 strategies to play, 5 offensive strategies that you can play, and 2 defensive strategies. So, but before I get there, I want to emphasize 2 somewhat unexpected characteristics of a decarbonizing world that I think are going to shape the nature of the economy going forward. The first one is the end of what I would like to call the energy flat world, okay? Oil is exquisitely dense from a volume point of view and from a weight point of view. Per unit of weight and per unit of volume, coal and oil pack an enormous amount of energy. That made it very cheap to transport. Actually, to transport oil, we have these huge things that can move oil around, and that made the price of oil essentially flat everywhere in the world. It means that if a barrel of oil costs $80 in, say, Saudi Arabia, FOB, it will cost you $82 or $83 in Japan, and $82 or $83 in Rotterdam. So it really, with $2, you can move a barrel of oil very, very far. And that meant that everybody was facing more or less the same cost of oil. That made the world energetically flat. And one of the consequences of that is that countries that didn't have energy could specialize in very energy-intensive products. So, for example, what you have at the top is who exports steel in the world. And you'll see that Germany, Belgium, China, South Korea, Japan export steel. And what do they import? And the bottom line, you have importers of oil. And who imports oil? Well, China, South Korea, Japan, Germany, etc. So these are countries that are major exporters of super energy intensive products. And since they don't have the energy, they just bring that energy in. But that assumes that the energy they're bringing in is cheap to transport, like oil. But other energy is not that easy to transport. For example, natural gas is very hard to transport. If you want to transport natural gas, you need a pipeline, and pipelines don't go everywhere. They just go from point A to point B. If you want to move it further, you have to liquefy natural gas, which is up here, right? And liquefying natural gas means to cooling it off. It costs in the US about 3 times the cost of natural gas to liquefy natural gas. So, and then natural gas liquefied is much harder to transport because you have to transport super cold and so on. And so you transport in relatively small ships like this, for which there aren't that many around the world. As a consequence, natural gas does not exhibit a flat world. This is the price of natural gas in Henry Hub in the US and in the Netherlands in the TTF market for Europe. And I checked this morning, and the price of Henry Hub is at $2, and the price $2 a million BTUs, and the price in Europe is $46 today. That's 23 times more than in the US. And by the way, that's euros. So add a little bit more to that. So it's really, there's nothing like the law of one price at all in natural gas. And I would put it to you that this current reality of natural gas, where countries face dramatically different prices in energy, is going to be a feature of the coming world. Now, this lack of flatness of the energy market today is something we're seeing in Europe. Now, energy-intensive European industries are incredibly uncompetitive as we speak, and they're trying to see where they are going to relocate. So part of the adjustment that is going to happen in the world is not going to happen only because regions that are today using fossil fuels are going to change their energy mix to renewable energy. I'm going to argue that renewable energy is much, much harder to transport. Think of that you're going to transport in hydrogen. Well, hydrogen is even less dense per unit of weight than natural gas. It's lighter than natural gas. If you want to liquefy it, it's going to take much more energy than liquefying natural gas. It's going to be harder to move. So nobody's thinking about that. Everybody's thinking about green ammonia or green methanol, but those are much less dense than oil, And it costs a lot of money and energy to move from hydrogen, green hydrogen, to green ammonia, and then to move the green ammonia. So you can imagine that companies, say in Europe, are going to have the option of running on green ammonia, say imported green ammonia in Europe, or using the energy that went into the hydrogen that went into the ammonia in the place where that electricity was generated. And I'm going to argue that this is going to make energy intensive products to want to locate back to energy to places that have rich, abundant sources of renewable energy. So how can your country grow by helping the world decarbonize? I'm going to mention these 5 offensive strategies. The first one is make the things that enable others to decarbonize. So to decarbonize, we're going to need solar panels, we're going to need windmills, we're going to need batteries, we're going to need to electrify things, or we're going to need electric cables. All of that requires a lot of metals, and metals are made out of minerals, and minerals come out of mining. So there is no way forward for the world to decarbonize without a mining boom and without an industrial processing of those minerals to produce the capital goods that will enable the world to decarbonize. So as I'd like to say, there is no way for us to save the atmosphere without scratching the earth. So here are some numbers. You know, this is the expected demand for some of these minerals that will be needed for batteries, for other instruments, for electrolyzers, for fuel cells, etc. Now, you might say, well, that's going to be good for the countries that have the resources. So here, what I'm showing you in green is where are the lithium reserves of the world. And in red, I have who is producing lithium today. And you see that the country with the largest reserves in the world is Bolivia. They have produced exactly 0. And Australia, which has about 1/3 of the reserves that Bolivia has, is the largest producer by far. And Chile, that has significant less reserves than Bolivia, is second in size there. So your natural endowment is not your destiny. You can mess up your destiny if you don't exploit intelligently your natural endowment. And so one of the critical things is going to be who is going to be able to create the environment where they can put those natural resources to use. Then you'll have to have, supply chains that they are able to transform all of these inputs into the capital goods. What are these products? Where are they in something we're going to call the product space? How close are these things to your current set of capabilities? Can you expand your set of capabilities into producing these things? That's going to be a question we would need to explore in detail. This is going to be the projected demand for solar power generation from here to 2030. It's many, many multiples that are at stake here. This is grid scale storage that will be demanded from here to 2030. If you're going to add more solar and wind, these variable sources of energy to a grid, you'll have to add a lot of storage capacity to the grid. So what are going to be this grid scale storage mechanisms? What are the technologies for there? Can your country participate in them? And so on. These are some of the things in the hydrogen supply chain. Where are these things? What do these things need? Does your country have what it takes to be a participant in this story? Second thing, so first strategy is, okay, so the world is going to need a lot of stuff to be able to decarbonize. Who's going to make the things that the world will need to decarbonize? That's strategy 1. Strategy 2 is, the world is no longer going to be flat from an energy point of view. Economic activities will want to locate close to their energy sources. So paper mills, used to locate near rivers because they used the water wheels to power the plant. Windmills are really factories in the Netherlands. That is, there's the wind, and you immediately use the energy of the wind to do things, either to mill wheat, to cut wood, to do a lot of stuff directly using the energy where the energy hits. I think we're going to move a little bit in that direction, that it's going to be much more efficient to use the energy where it hits, because moving that energy is going to be costly. This is an aluminum smelter in Norway. That aluminum smelter is there because there's hydropower there, and it wants to locate near where the hydropower is. And so you have this co-location of energy-intensive industries in places that have cheap renewable energy available. So that's, we call it, that said in a different way, if you are able to develop green sources of cheap sources of green energy, you will benefit from the relocation of energy-intensive activities towards places that have cheap renewable energy. But on the other side, the second feature of this world that we need to focus on is the cost of capital. And all of these new sources of energy have the feature that their operating costs are relatively low, simply because the wind blows for free, the sun shines for free, the rain falls for free. So you don't have to pay for your inputs if you want. So the bulk of the cost is how costly it is for you to install the capacity. That has to do with how efficient you are at licensing projects, as evaluating projects, as doing the engineering, installing the capacity, procuring the materials, etc. But then the cost of capital. And the cost of capital is a very, very significant part of the competitiveness of the projects. And countries differ enormously in the cost of capital that they face. Here, I'm only putting the yield on government sovereign bonds. And government sovereign bonds have typically a lower risk and consequently a lower interest rate than activities and investments that go into specific projects that have, in addition to the risk of the country as a whole, will have industry-specific risk, project-specific risk, technological risk, commercial risks, and so on. So this is sort of like a floor of the cost of capital, but there's an enormous inequality in the cost of capital in different countries. So if you don't worry about your cost of capital, you may face very high cost of capital, which will mean that, for example, you may have 3 times the insolation rate, the amount of sun rays that the sun emits that you can capture, that a solar panel can capture in your country than, say, Germany has. But if you have a significantly higher cost of capital than Germany, your cost of energy is actually could be more expensive than that of Germany, because you have to pay so much more for your capital. This means that from a world point of view, it's a super inefficiency. So if, for example, the Dominican Republic has 3 times the insolation rate of Germany, it may be that it's still cheaper, the electricity you get out of a solar panel in Germany, because the cost of capital is so much lower. And that means that the world, to generate the same amount of energy, will need 3 times the solar panels, because it's putting them in Germany instead of putting them where the sun is strong. Okay, so the cost of capital is going to be a huge determinant of where capital gets installed. It was a little bit behind these pictures that Dan showed that as to where is the capacity being installed, but this is going to be an important issue going forward. What can you do to control the cost of capital? And the cost of capital is related to a bunch of risks that countries have to figure how to reduce. There's the sovereign risk, the regulatory risk, currency risk, transfer risk, off-taker risk, etc. So the third strategy that you can think about is how can you monetize carbon sinks? There's a lot of effort at trying to figure out ways in which you can use either nature or technology to capture carbon. There's, projects of reforestation or forest protection in the Amazon or elsewhere, where carbon credits can be emitted, can be issued, and people can buy those carbon credits and so on. There's technology using maybe biochar and pyrolysis to capture carbon and sequester in useful ways. But for this to happen, it needs a market. And this is a picture of, on the y-axis, you have the price of carbon per ton. And on the x-axis, you have what percentage of the carbon emissions are subject to carbon trading. And what you see is this enormous diversity of prices. In some places, they're paying in excess of $100 a ton of CO2. And in other places, like say in Colombia, they are paying $5 a ton. Now, there's a bunch of investments in carbon capture that look incredibly profitable at 100, but not at 5. What are the different costs of different ways of capturing a CO2 using nature or using other things, and what is the world going to pay for? In general, when an economist sees a picture like that, he says, look, this is incredibly inefficient because the Swiss or the Swedish should be able to find people in Colombia or in Brazil that would have a much better technology to capture that CO2 at much lower cost. So, we would like to see a relatively homogeneous global price for carbon so that the efforts are efficiently allocated worldwide. Here, developing this market may generate an important source of revenue for countries that are going to be exporting, if you want, carbon capture. The first idea is that because you are going to do some of these things, you're going to be accumulating some capabilities. And those capabilities go into making the things you're going to make to help the world decarbonize, but they also go into many other things. These initiatives, these investments can become stepping stones into other things that have nothing to do with decarbonization. But you will have like an adrenaline shot, a push from the fact that you will have developed infrastructure capabilities, investments that will power other things going forward. And finally, you can create an export know-how. For example, Navarra is a place in Spain that got very quickly into wind power in the 1990s. In the end, a lot of the windmills ended up being produced in China, but the engineering, procurement, and construction of many of the projects around the world are done by the people who developed the knowledge on how to do it at home, and those are in Navarra and in the rest of Spain. So there's a lot of value to be created, and not just in the manufacturing of the things, but in the engineering, procurement, construction of the things that the world is going to need. There's a lot of knowledge of how to do these things that the world is going to need. And you're probably going to need two defensive strategies. One is what to do with your gray industries, what kind of constraints are they going to be facing going forward. There's going to be this carbon border adjustment mechanism, CBAM, in Europe, probably extended elsewhere. And there's probably going to be a lot of impact that climate change is going to do to your country that will force you to invest in adaptation to protect your production and your livelihood. So those are two defensive strategies that you have to be aware of. But in some, the world needs to decarbonize. The world is going to need a lot of things in order to be able to decarbonize. can your countries grow by producing those things that the world will need to decarbonize? And what are those things? Do you have what it takes? And what do you need to do to materialize these opportunities in a productive manner? So those are the things that I wanted to share with you. Let me stop there and let's open it up for discussion.
Ricardo, I'm just going to show one quick slide, couple of very quick things before we there's so many questions in the chat that I don't know how we're going to get through all of them, but let me just show you one very quick picture, because I think this sums up what Ricardo is saying, gives you a scale. This is from the IEA. This is global energy investment over the last 5 years or so. You see it's around a little more than $2 trillion a year. Power sector, you can think of the bottom as fuel, the dark green, and then the light blue is end use and efficiency. But if you actually look at the clean energy investment, it's actually becoming enormous. Just 10 years ago, this would have been just a couple $100 billion. And now it's over $1 trillion when you look at the parts. For example, look at the EV component that's coming on so strong. Now over $100 billion a year. Huge investments in renewable power, but also energy efficiency, grids and storage, low carbon fuels also growing dramatically. This is really exciting. This is per capita clean energy investment in different countries, in different sectors. You see in blue, the advanced economies and China, and this is happening. But what's not yet happening is that same scale of investment in developing economies. And this is the green growth opportunity. It's not yet realized. And, you know, the figure on the right showing the total investment over the last 3 years, there were a few things going on in the world in the last few years. So there's some reasons why things got a little bit off track during the pandemic. But I think the important thing is to recognize the opportunities and think about the policies, some of which are protectionist and discourage the kind of trade opportunities that we think are there. But I think the scale of this is just unbelievable, and the opportunity for economic growth around the world driven by green policies in the rich countries, I think is just unbelievable. So let's stop there, and Ricardo, maybe we can take a little bit of response to questions and discussion.
Great, thank you both. And yes, it's been so fascinating to see all the questions coming into the Q&A. I think we'll have time for a couple of them. So one question that came in was from James Collister, and he wanted to know, what are the key actions that local government should prioritize in order to facilitate and deliver green growth?
Well, I think that the space of change is so large and the potential roles that you can play are very different. So that's why we're going to take a week to explore all of these options. There are some countries that are going to participate in the value chains that are going to produce the enablers of others' decarbonization. There are other countries that are going to be able to attract investments that want to do things in a clean way because they have already green their energy sources. For example, Costa Rica has 99% green energy. So if you want to control your carbon emissions, you know that you go to Costa Rica, it's plug and play. You don't have to be doing carbon accounting and stuff like that because their energy is already clean. So that's an investment theme. And there are countries that are thinking about, how do I put in a place the ecosystem necessary, the clusters necessary for some of these activities to happen? For example, Indonesia is, they thought, we have a lot of nickel, lithium-ion batteries use a lot of nickel. So we want to use the fact that we have the nickel here, but we have 200 million people here. Plus we are members of ASEAN to maybe say, look, if you come and invest here to process the nickel into lithium-ion batteries, and you want to target our market to produce cars and electric motorcycles, for the local market in ASEAN, then I'll give you preferential access to the nickel and so on. So they're thinking of an industrialization strategy that is based on these new technologies, and they are thinking of it in terms of the new things that they will be globally competitive in because they're going to be serving this global need, leveraging the domestic market. But there are plenty of others. I could go on, and that's exactly the beauty of the course. Try to explore these many different avenues. There is, biomass is probably going to be at a premium going forward. And what are the technologies that could process biomass and to make interesting things with it? And biomass grows more easily in the tropics than elsewhere. So what are the energy intensive things that will be able to be produced or demanded coming from those regions? There's sustainable aviation fuels and other hard to decarbonize industries that will probably be in demand of those things. So that's exactly what we want to do in the course. It's explore this enormous space of possibilities and develop a technique to figure out how suitable you are to those possibilities and how close are your set of capabilities to those opportunities.
Yeah, I think it's really important to understand, and this is the point of the course, that it's not simple, that this energy transition is not just obvious investments in technology that are always going to be clear cut. There are often competing approaches. For example, for trucks or ships, are they going to run on hydrogen produced from renewable electricity? Are they going to run on ammonia that might be produced also in a green way? Or are they going to be run on biofuels, for example, that Ricardo was just talking about? And the answer is today, we don't know. We're in the very early stages of this process. And so it's part of the point of the course is to think through the technologies, some of the constraints, and also the political and policy dimensions of this that allow some countries to have more favorable outcomes in this global race than others.
Great, thank you. Speaking of the course, can you both talk a little bit about who should attend, who should come to this program? We have a lot of people from all over the world and in various sectors. So could you share a little bit about your thoughts on that?
Sure. I mean, the Kennedy School has, offerings on environmental policy, and what should the world do to create a policy regime that will encourage decarbonization, and what commitments and international agreements should do or not do, and what national environmental policy should be. This is not that course. This is a course on how does a decarbonizing world change the development opportunities of nations. And so it's really a course more for people who are thinking of growth and growth opportunities, whether you are ministries of finance, ministers of economy, people in the private sector, investors that are looking for investment opportunities in a world that is decarbonizing and trying to understand how that's going to shape the competitive landscape. And for governments and for people, say the policy wonks of countries, it's important that they start rethinking their whole growth strategies in light of the coming changes to the global economy. And my hope is that countries will relatively quickly find interesting strategic bets to pursue. And we're seeing it increasingly. There's these green hydrogen projects that are large in Namibia and in Chile and in Western Australia and in Oman, where there is these commitments to buy hydrogen from the European Union, and there's the hope that there will be some off-takers to that expensive green hydrogen. We're going to discuss the risks. So we're very much anti-hype. So the hype is not where it's at, but it's to look at opportunities and to analyze the risks and to analyze the things that governments can do to de-risk and to make more viable, and talk to investors who are looking at ways in which how they should look at the world and the opportunities in the world to deploy capital.
Thank you both. Unfortunately, we're out of time for today, but we will be sharing some more information on the screen right now and in the chat about the program. I really want to thank Professors Hausmann and Schrag for their time today. Obviously, this is a very complex and global topic that we have a lot of interest in. The Q&A. If the Q&A is any indication of what's to come in the program, I think everyone is in for an exciting and engaging week on campus. So thank you again, Ricardo and Dan, and thank you to all the participants who joined us today. If you have questions about the program, please feel free to email the program director, Jesse Delano. As I said, you will all be receiving the recording of the session with more information on the Leading Green Growth program that will happen in August. So thank you again, everybody, and be well out in the world.